So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as long answer questions on database management system. So we have almost covered all the topics in this database management system. So what type of questions we can understand, we can learn which type of long type of answer questions can come in the exams and how to answer that type of questions that we will be discussing today. So let us start with the questions, which type of questions we are going to solve, how in which way we are going to solve that we are going to learn today. So, like questions, these are the long answer questions like explore GIS data file management, detailing the methods, procedures used for storing or organizing geographic information within a GIS. So, explore data file management means what is data file management? First of all, we should know about type of data, which type of data we are using, how we are using that data, which way we are trying to use that data, and what type of data we are going to use, so that all type of data, how we are going to manage, how we are going to store, and how we are going to do the analysis of that data. So here when you talk about database management system is about the storage, the file storage, whatever data we are trying to store in a database form, which a GIS setup has, where it can save the both raster data and vector data, as well as the data of uh, raster, vector, spatial and non-spatial data. When this data is stored in such kind of DBMS, then only this data can be managed properly. Now, first of all, we have to split this question in two forms. Explore GIS data file management. So, first of all, if you want to answer this question, we have to answer the question first of all about GIS data file management. So, what is GIS data file management? This we have to discuss first. So, like basic data types such as integers or real numbers are extended into spatial data types such as points, polylines, and polygons. So, in like all this data is extended into spatial data types such as points, polylines, and polygons. So, points, polyline, and polygons, these are the data types which are extended in this file management in the spatial data structure. Operations which constitute the capabilities that manipulate the data structures and as such as when the sequence into the operational workflows in the specific ways to generate information from the data. So one might say the new relationship constitute the information from the data. Now different data models will design the results in the different combinations of the structures of operations and rules which combine into the various SDBMS. So what is SDBMS here is the database management system, the spatial database management system, like wherever you store the spatial data of what is the spatial data that you know. Spatial data is like the things, whatever you see around you, all the geographical features which is on the earth surface, that all information, whatever we see around us, that comes under the spatial data set. What is non-spatial data here? Non-spatial data is the information about spatial data is a non-spatial data. So SDBMS which combines into the various SDBMS products. Now spatial database management system, both software and hardware subcomponents will organize the data for enumerating and querying databases conducting the spatial analysis, and it will help us to create the map visualizations within an integrated manner for managing the large data stores. Now, database management is a subset of a larger category of technology. It is called as a data management technology. The data are managed using two types of computer-based physical files and logical files. So now this database is managed with two types of files. One is the physical and one is the logical. Now what is a physical file here? So physical file is the collection of records managed by the operating system. So physical file will be the managed by the operating system. All the files which are recorded by the which is collected by the system, which is by the operating system, that all files are called as system software and stored on the disk. A data file being different than a database file. Now, logical file is a file that is the collection of records managed by the application software, more fundamentally database management system software. So a logical file is a collection of files. It's a collection of files which is managed by the application software, and here fundamentally database management system software. Now, if you see the physical file, how it is managed by the operating system. So operating system software where the data is stored on the disk or data file being different than a database, that is called as physical file here. And now logical file means it's a collection of records which is managed by the application software and most fundamentally the database management system software. So these two files are managed by the DBMS. One is physical, one is logical. So as we know, physical is the operating system, logical is managed by the application. So what is the application here? So the software which we use in the system, so that software will be managing this application part. So many logical files can be combined into physical files. Methods and procedures used for storing and organized GIS. So the different types of information which is required for GIS requires storage, which allows the information to be updated and queried for analysis by the users. So the different types of information which we require. Now, what are the methods? First of all, we have just understood about this file management, data file management. So how the file is managed, physical and logical files. Types of the data we have seen, spatial and non-spatial data, raster and vector data to be managed by this GIS data file management. Now we have here methods and procedures which are used for storing and organizing the GIS. How do we use and store this and organize the GIS? Is the different types of informations which is required for a GIS require storage which allows the information to be updated and queried by the for analysis by the users. So these different types of information which will require the storage, which will allows the information to be updated and it will query it for the users by the analysis purpose. So there are two types of information to be stored in the DBMS. So the two types of information what we have here is spatial data and attribute data. So these two types of information, spatial data and attribute data. What is spatial data here? Spatial data is about the data what we see around us, all the geographical features which are on the Earth's surface, that all comes under the spatial data. And non-spatial data is like the spatial, non-spatial data we can say, even we can say the attribute data. Attribute data is also known as a non-spatial data. So spatial data is usually stored as the themes, layers and coverages. So these three things, wherever you see the spatial data, how it is stored in the DBMS, it is stored as the themes, it is stored as the layers, and it is stored as the coverages in the DBMS. DBMS is Database Management System. Now, data storage and retrieval and management. So, how do we store the data? How do we retrieve the data? This all management process. How do we do? So, first of all, if DBMS is properly working, when it is having the compatibility, when it is having the run setup is the flow of the data where it is saved. So there are different types of information which is required for a GIS, requires storage, which allows the information to be updated and queried for the analysis by the users. So there are different types of information which is required for GIS and which requires the storage, which allows the information to be updated and queried for analysis by the users. So there are two types of information to be stored. So what are the two types of information you see? Spatial and attribute. So every time when you talk about data, when you talk about database, so we have two types of information which are stored in this attribute data, spatial data and attribute data. So that type of information is like attribute data is the data which we also call as non-spatial data. Okay, non-spatial data. So attribute data, spatial and non-spatial data. So this spatial data is usually stored as themes, layers and coverages. We can store the information in the form of themes, layers and coverages. So the georeference spatial data is displayed in GIS in its proper place in relation to the other spatial data because of the geographic georeference information attached to the data. So what is the georeference data? So when you talk about the georeference data is the data which is having the coordinate system assigned to it. Okay, coordinate system, coordinate system assigned to the data. Okay, coordinate system assigned to the data is called as the georeference data, where you can just assign the coordinates, you can assign the GCP points and try to run the process and try to georeference the data. Georeference means once you assign the locations, when you assign the exact locations to the map, so that locations will be helping us in the assigning the coordinates to the maps. So once you assign the coordinates to the map, then the data will be easily fixed to its location. So georeference data, spatial data, this all type of information will be saved in the database of GIS. So in the proper place and relation to the other data because of the georeference information attached to the data. So an example could be the latitude and longitude in decimal degrees. So these examples are latitude and the other examples are longitude in the decimal degrees. So we use the latitude and the longitude in the decimal degrees to just try to georeference the information on the map. Now the latitude and longitude. So what is the latitude and longitude? So these are the two coordinates. We can say x and y coordinates. So x and y coordinates. This school is like embedded in the file, so it will be displayed in GIS in the proper location in relation to the other features in the city. So how can we just identify these latitudes and longitude once you assign the coordinates, x and y coordinates we say. So latitude is we can say 0 to 90 degrees up or 0 to 90 degrees down. Okay, so this is called as latitude. So it will either increase or decrease, right? Now if you talk about the longitude, it is like uh, from here 0 to 180 degrees east and 180 degrees west. So this is how we see the latitude and the longitude in the locations if you want to assign. So themes can be anything that are currently located on traditional paper maps such as roads, rivers, cities, wells, forest boundaries, school districts, boundaries, etc. And they are all georeferenced. So themes can be anything like they can be located on the traditional papers such as roads, such as rivers, cities, wells, forest boundaries, school district boundaries, etc. And they are all georeferenced. Now coming to the attribute data. So what is the attribute data? So attribute data is the information about an object or a feature. It is an information about an object or a feature. So an example could be our school, its name, location, what districts, how many children attend each year, etc. So attribute data is information about the object, about the feature. Example could be our school, its name and location, what district, and how many children attend each year. So this is all about the information about the tables. We can say tables or figures information when you give. So these tables and figures information we call it about the attribute informations which will help us. It's a name and location which will help us to give the information about the spatial data. So this is like if we talk about the attribute data, it is an example of a school. So if you talk about the schools, so what is the name of the school, what is the location of the school, what type of which district it is located, how many children are attending each year, how many children are attending every day. So this all information it comes under the attribute information. Then what about the spatial information here? Spatial information is about the location, about the building, about the structure, that all comes about the spatial information in the building. Now storage medium. How do we store the data in DBMS? The storage media here we have here is, so data is stored on the variety of physical media depending on how quickly the data needs to be assessed, how quickly the data needs to be assessed. So how much data needs to be stored and whether the data needs to continue to exist or when the digital device is turned off or rebooted. So that all information is stored in the DBMS, database management. So what is the variety of physical media and how quickly it is depending on the data needs and how quickly we are able to access the data. So how much data needs to be stored and whether the data needs to continue to exist and when the digital device is turned off or rebooted, what is the storage capacity of the data is given there. Now RAM. So under this storage you can see random access memory RAM. RAM is a very important part here to run the system memory to be run down. So for that, random access memory should be very fast. Like it should have more number of, I mean, the memory should be more. Then only the processor will run faster. Then magnetic hard disk is required. Flash memory is required. Magnetic floppy disk is required. Magnetic tape is required. So these all things are required to just run the system, and the data should be stored in such a hardware like where we can save this information. So hardwares are required here is RAM, magnetic hard disk, we require a flash memory, we require a magnetic floppy disk, we require a magnetic tape. So this all devices, if it is present in the setup, that means we are able to run the system properly, the setup properly, and the data can be stored in such kind of devices. Now, storage formats. So we have here different storage formats. So there are different storage formats like geospatial data can be stored in a number of different types. It can be stored in a number of different types of digital files on the physical media described. So the data, geospatial data can be stored in the any type of data storage formats which we have just now seen in the previous slide. And the following are the file types you will commonly encounter when performing the basic GIS data. Now graphical maps. What is a graphical map here? So graphical map is the geospatial data can be stored in simple table formats like comma separate variable files and the columns of latitude and longitude associated on each row with a specific attributes at those latitudes and longitudes. However, this largely limited to the points rather than the area. So they are limited to the points rather than the areas. And shapefiles, this CSV file, it is stored in the file format, table file format like Excel sheets. We can store this information as a attribute data, and this information can be easily stored and viewed properly. Now coming to the shapefile. So what is a shapefile here? So to store the spatial data, shapefile is required. Spatial and non-spatial data, shapefile is required. So shape is file is actually a collection of at least three and unusually more separate files that are stored in the location data. So these characteristics associated with those locations and other information about the data. So some common files associated with the shapefile include listed by the extension file. So what are the three types of shapefile we use here is one is point, okay, point, the other one is line, and the other one is polygon. So we have these three types of data: point, line, and polygon. These three types of data we use in the GIS process, where we can just get the information about the spatial and non-spatial, spatial and non-spatial. This information can be received by the spatial and the other one is non-spatial. So what kind of shapefiles it has an extension here. So immediately once you create a shapefile, so once you create a point, okay, let us say once you create a point. So point is a shape. So if you create a point, the first extension file will be created is .shp, which contains the features geometry, points, line, and polygon. So it will contain the feature geometry along with the points, along with the line, along with the polygon. Now next thing is created is .shx. So .shx and .dbf. So these three files are immediately created once a point shapefile is created. Shapefile is created. Either line shapefile is created, either polygon shapefile is created. So based on the requirement, the shapefile will be created and it will be containing the feature geometry. .shx, it will contain the file which indicates the specific features. in the shapefile, and .dbf is the database file of the attributes which is associated with each of the shapes in the .shp file. Now .prg is the coordinate system and projection used by the feature geometry. This is the optional. .prg is the optional here. So whether it is created or not, based on that, the after the digitization process, this file will be created. Next we have .cpg. So .cpg, the character encoding used by the attributes, and this is also optional whether it is created or not, based on the requirement base. The shapefile, the dot extension files are created in the database. Okay. So this is how the shapefile is working here. So this is how we can answer the questions here. Now coming to the next question here, that is provide an introduction to GIS. Provide introduction to GIS, emphasizing its role in the spatial data management and analysis. Discuss its applications and across the various domains. So if you remember about GIS part when we have studied in our previous lectures, what is GIS? So basically GIS is a setup of computer hardware and software where you can store the data, manipulate the data, do the analysis, do the uh, manipulation or storing or checking or displaying or updating. This all information we can do with the GIS. So introduction to GIS, a geographical information system, is a computer system for storing, checking, and displaying data related to positions on the Earth's surface. It will help us to relate the positions on the Earth's surface, and GIS can show how many different kinds of data on one map, and it can tell us about the streets, it can tell us about the buildings and vegetation. It can every uses of geospatial data has experienced the challenge of obtaining and organizing, storing, sharing, and visualizing the data. So every users of geospatial data has experienced the challenge of obtaining, organizing, storing, sharing, and visualizing their data. So the variety of formats that data structure as well as the disparate quality of geospatial data can result in dizzying. So it can result in the dizzying, an accumulation of useful and useless pieces of spatially explicit information that must be poked, prodded, or wrangled into a single unified data sets. So accumulation of useful and useless pieces of spatial data must be prodded or wrangled into a single unified data set. Now the basic concerns related to the data acquisition and management of the various formats, the qualities of geospatial data currently available for use in the modern geographical information system projects. So the true power of GIS lies in the ability to perform the analysis. The true power of GIS here, it lies in the ability to perform the analysis. Spatial analysis is a process in which you model problems geographically, derive results by computer processing, and then explore the examine those results. So spatial analysis is a process where you can just which you model the problems geographically, and we can derive the results by processing of the computer, by exploring, by examining the results. So what is the technology? The technology of the spatial analysis has widespread and its applications both in the private and public sectors. It can be used to benefit local communities, it can be on habitats, and also tackle the global challenges here. Now coming to this next slide, analyzing the time lapse spatial data can identify the patterns and trends and predict the future. It can predict the future events, and it can, with a great accuracy, it can predict the future events with a great accuracy. The manual analysis of images captured by the satellites is time consuming and expensive. Manual analysis of images is captured by the satellites, it is time consuming and it's very expensive here. It is also prone to errors. So spatial data analytics employs AI and ML applications to process the vast amounts of data at a fraction of the cost, time, and with a high degree of precision is done with this GIS process. Now applications here. So when you talk about the applications of GIS, what are the different applications here? So it has a very wide applications here. So first of all, few of the applications we will learn, like agricultural applications, forestry applications, range applications, water resource applications, urban and regional planning, and we have wetland mapping. So these are all applications. These are few of the applications. It has many applications in the GIS process. So few of the applications is this. So here we are going to learn this one by one, and we have some more here: land use, land cover mapping, geological and soil mapping, wildlife ecology applications, archaeological applications, environmental impact assessment, monitoring and management applications. So it has very wide applications in almost all the fields, in the land use pattern, in the geological soil, in the wildlife, in the archaeology, in the environmental assessment, in the water resource, in the forest, in the rangeland, in agriculture, wetland mapping. So many applications that GIS is having here. So let us start with few of the applications. Let us understand here. So agricultural applications. So here the technological innovations, geospatial technology help in creating the dynamic and competitive agriculture, which is protective of environment, capable of providing excellent nutrition to the people. Why? Natural inputs on farming, how in the cannot be controlled. They can be better understood and managed with the GIS application. So in the agriculture application, GIS will give us very helpful technology to just finally locate the crop, and it will tell us about the yield estimation of the crop, how much crop is going to uh, how much yield is going to occur in this year. So total yield estimation we can go through. We can just find out the precise location, in which locations which type of crops can be grown. So that all information we can get through GIS, and how much area is damaged, or how much area is to be uh, agriculture areas to be converted, and how much crop to be grown. That all information we can get through GIS process. So it has a very wide applications here. GIS can substantially help to effective crop yield estimates and soil amendment, analysis, erosion identification, and remediation. Now, forestry applications. When we talk about forestry applications, geographical information system is an amazing technology that is used to create a public policies related to forests, related to the environmental planning. So this technology has been responsible for the decision making process for a couple of years now. Now, GIS together with other foresting technologies have helped the foresters and environmentalists to keep the clear record. So GIS will help us, first of all, it will help us to take a decision to just whether to clear the forest, or whether to help the forest, or any information related to forest fire, any information related to some policies to be implemented in the GIS in the forestry department. And regarding to the forest make decisions, they will help us to make decisions based on the data which is obtained, and with the rapid advancement of technology. So GIS is becoming a popular every day, like, due to the immense benefit to the environment. So once it is given the immense benefit to the environment, it is becoming very popular nowadays, and it is applicable in almost like all the forest applications, either planting the trees, cutting of the trees, how much resources are present over there, how much resources are damaged, or whether this area is suitable for any more plantations or not. That all information is given by the GIS. Now, water resource applications, this is also very wide applications of GIS. So, GIS is, however, it is used in the various activities which is involving water management. Water management using GIS is beneficial for monitoring the water resources. It will help us to tell us the water resource places, which area is covered with the water resource, how much area is having the groundwater problem, which area is full of water, and which area is has a problems in the water, or water is contaminated, or water is not good for health. That all information that GIS can give us. So first of all, total quantity and the quality of water can be given through the GIS process. Now, urban and regional planning applications, how this GIS is helpful in the urban and regional planning applications. So GIS in urban planning enables spatial analysis, modeling, which can contribute to the variety of important urban planning tasks, and these tasks includes the site selection, land suitability analysis, land use, transport modeling, identification of planning, action areas, and the impact assessments. So it will helpful in the urban and regional planning, where the places it is helpful is land suitability analysis and land use patterns, transport modeling, planning of the areas and what are the impacts and how to assess that impacts at all. It is uh, helpful. Now DBMS applications, if you see how the DBMS is helpful in the different applications here. So DBMS applications we have here is railway and railway reservation system, library management system, banking, education sector, credit card exchanges, social media sites, broadcast communication. So here DBMS application, how it is helpful in the railway reservation system. So when you go for a reservation, when any reservation to be done, so a lot of data is feeded in the system. So once you want to travel from one place to the other place, so all the information before itself is saved in the database. So once a person is just want to enter the details there, they have to travel from place to the other place. So once they enter the details, they will get to know about the fare, about the distance traveled, and seat availability, and which train which is going to travel from one place to the other place, and how many types of trains are there. That all information is given by the DBMS. So DBMS is helpful in this. This all applications is very much useful to do this railway reservation system. Now here library management system. Library management system. If you have a central library. So in the central library, you have so many books, lot of books you have. So to manage that books, every book entry is given to the setup of DBMS. All the book entry, what volume it is, what is the name of the book, what is the name of the author, and what is the idea of the book, and it is written by whom. That all information is just entered in a table, and that information is saved in the DBMS file. So from the central library, if you want to monitor the information, if you want to receive any book, if you want to return any book set, all information is added in the DBMS. Suppose a student is going to just take a book from the library or borrow a book from the library, then that information of the student, its ID number, it's the book number, the author number, the volume number, everything is entered in the DBMS file. So this is how this database is managed. So database is managed. Any organization, they need a proper database which to be managed by the organization setup. So once the data is fed in this organization setup, then they can retrieve the data at any point of time. Now banking also, it's the same type of data, the information which is stored in the banking purpose, the data information, the how much amount is there, how much credit is there, how much debit is there, what is the balance of each and every employee, what is the balance of each and every customer. That all information is saved in a banking DBMS. So once you enter the ID of that or account number of the person, it will show you the entire information about the person. So how we are able to see, because the entire data is fed in the DBMS, the entire information is fed in the DBMS. That's how we are able to just check about the banking process. We are able to get the information. Now, same thing in the education sector. When you apply in the education sector, what is the roll number of the student? What is the ID of the student? Which class, which department, and which college? That all information is given. How much marks he got in his 10th class? How much marks he got in his ranking? That all ranking information also it is just fed in the application, and the data is saved in the database. To just retrieve that information, we are able to, after retrieving that information, we are able to get to know the entire information, and we are able to find out the information about the student. So once you just put the roll number of the student, we are able to see all the credits of the student, whether results of the student, whether pass or fail. That all information we can just get to know in the education sector once with the database file. Once the database file is ready in this computer system. Now credit and credit card exchanges, here also when you talk about the credit card exchanges. So whatever exchange is there, what is the credit number, how much amount to be debited from which card holder, that all information also it is helpful in this DBMS in the credit card exchanges also. Social media sites is also nowadays it's playing a very important role. So whatever data we feed in the social media, it is saved at the place, and whatever we need from that social media, any information to be received, any information to be added, that all easily add and we can easily just get to know this information about that social media also. Now, broadcast communication. So, what is the broadcast communication? We can just get to know about the broadcast information. We can just communicate about this, which the list of the channels, the list of the what do you say, telephone directory, the list of the internet websites and all that. All list is saved in this computer system and in the website in the database management tool. How we are able to search in Google, because all the information is just stored in the database. From the database only, it gives us a reply to the questions what we query there. So whatever we put a query over there, so that all queries are just given by the information is given by the database, and that will help us to just retrieve the information, and that will help us to give the information to us. So this is how we can just solve this questions and answer problems, and we can give these answers to the questions. So these are the few references you can just go through to find out the more contents about this information. Like you can go through the MNG book by various publications and online links. You can just go through to find out the more content about this database management system, and you can answer the questions, this long answer questions in this way. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.